Hello guys, Jose Rodriguez here. In this video, I'll show you how can you complete the CAN bus challenge from the network traffic analysis module. Okay, we have this C code that we can use as a reference on how to parse every packet within this pickup file. Okay, CAN dump. And we also have the solution guide here that I recommend you guys read carefully, especially the video. Okay, you should watch the video from the Cyber Skyline team, because here is where they explain to you a little bit more about the CAN bus protocol or the CAN protocol and how can you use it in real life. Okay, and then something important about this is that one of the questions asked about speed update messages, and apparently the way to identify these type of messages is by the ID value, which is 589. Okay, and they also suggest that you download or create a CSV file sorry, using Wireshark. Okay, so I recommend you guys review these and see all the different suggestions, okay, so you can complete the challenge. But for this video, I'll use a different approach. I will use Python to read the content of every packet and try to extract the answers for these questions, okay. As you can see here, I already solved the challenge. It's funny because after recording the video, I realized that the audio was not working properly. So I'll need to, but I'll let you know what are the answers for each question. Okay, what are the values that you need to type. Okay, so the first thing that you need to do is you need to download the pickup file. Okay, so I just downloaded the file here. As you can see, is under the downloads folder. And as always, the first thing that you need to do is you need to validate the MD5 hash for this file, okay, just to be sure that you downloaded the correct file. So let me copy this to my clipboard, and then I'm going to open my terminal. Okay, let me increase the size of this. Okay, so what I'm going to do is calculate, okay, the MD5 hash of this pickup file that is in my downloads folder. Okay, so here's the MD5 hash, and this is the hash from the NCL website, and as you can see, it's the same value. Okay, so that means that we downloaded the correct file. Okay, so let me clear the screen here, and once you have the pickup file, you just to access this content quickly, you can just open the file using Wireshark. Okay, and here you can see all the different packets. Okay, and it looks like all of them are using the CAN protocol, so there is no need to filter anything based on the protocol. All of them are part of the CAN protocol. By the way, CAN stands for Controller Area Network. Okay, and you can see here all the different IDs, and if we click on the first one is actually a 589 packet, which is a speed update message. You have the frame, you have the exported PDU section, the control area network, and also the data section here. Okay, and if I'm not mistaken, one of the questions asked for the speed value, and just so you know, the speed value is part of the data section here, and it's this value here. Okay, it's an arrangement of 5 bytes. Okay, and after reading the solution guide, you will see that we have 5 bytes to represent the speed value, but it looks like we are only using the last 2 positions. Okay, so there are 5 elements here, and there are positions start always from 0, apparently. So it's position 0, position 1, position 2, position 3, position 4. Okay? That's actually why if you go to the code and when you read the explanation of the code, they are starting in position 3 to get the value of the speed. So they are using position 3 and position 4. Okay? And it's basically because of this, because they are just using, I mean, this is just for this pickup file. Okay? I guess in a different setting, we may use more than 2 positions. Okay? So we are only using position 3 and position 4. Okay? So this is using Wireshark, but again, I'll show you how can you use Python to access and process all this information. Okay? So let's go to the terminal, and what we are going to do is we are going to create a Python script. Okay? But before we do that, the library that we are going to use is called PyShark. Okay? So what we need to be sure is that you have PyShark installed in your computer, and to do that, you need to do pip install PyShark. Okay, I already installed this library, so that's why it says requirements already satisfied. But if it is the first time you're running this command, you will see that the pip utility will start downloading all the required files for this library. Okay, and then after that, you can let me increase the size a little bit more. Okay, so now you can start creating a Python script. You can use whatever utility is more you feel more comfortable with. I want to use Nano, and I will call this script can-dump.py. Okay, and the first thing that we need to do is we need to import the library. Okay, so that'll be PyShark, and then we need to also make reference to the file. Okay, I'm going to call this pickup_file. Okay, and then it's going to be a string with a path to the file. So this is under home, Kali, downloads. Okay, and the name of the file is can-dump.py. Okay, and then what we are going to do is we're going to use this file to create a PyShark file capture object. Okay, so we can access all the different packets that are within this file. Okay, and I will call this object can, okay, equals to PyShark, okay, dot file capture, and then the parameter. There are more parameters that you can use, but the first one is the path to the file, okay, to the pickup file. So I want to use pickup underscore file. Okay. And then just to show you the content of this file, what I'm going to do is, so this will create an arrangement where each element is every packet. So to access all these different packets, I'm going to use a for loop. Okay. So what I want to say is for packet in can, which is the object. Okay. Let's just start by printing the first element, so the packet. Okay, and I'm gonna add a break statement here because I just want to print the first element. Okay, I want to explore the schema of the packet. Okay, so then we can do Control X just to save, enter, and then let's run the script. So we can do Python space and then the name of the script. It's actually the path. I'm just using the name because my script is in my current directory. But if you create your script in a different directory, don't forget to add all the path to the specific file. Okay. So let's run this. Oh, there is an error. Apparently, I typed this incorrectly. Okay, so let me see. Let's go to the file. What is the path to this one? Properties. That's weird. Yeah, I used it right. Oh. It's not .py, it's .pcap. Okay, my bad, I'm sorry. So let's just modify this really quick. So it's pcap. Okay, Control X, Y, enter. Let me clear the screen and let's run this again. Okay, so this is the first packet. Okay, if you remove the break statement, or if you comment the break statement, Python will start printing all the different packets. Okay, and as you can see, we have this. It looks kind of similar to what we get in Wireshark. Okay, we have the exported PDU section. We can see, looks like this is a layer. So we have the exported PDU layer here. See, and then we have the controller area network or CAN layer. You can see same information, and we have the data section here. I guess the only difference is that we don't see this information here, but I'll show you in a little bit that is there. It's just that it is not printing the values. Okay, nice. So it looks like we have layers, and actually what you can do is you can access all the different layers. Okay, and to do that, what you can do is, let's go to the script again, and for example, you can add here. Okay, let's print. Let's add another print statement. Okay, let's add a line so you can differentiate the output of every print statement. Okay, so let's do print, and you can do for the packet. Okay, it has a method that is called layers. Okay, so you can see all the different layers in this packet, and I'm expecting to get 3 layers. The PDU section, the CAN section, and the data section. So let's see. Let's do Control X, yes, enter, and we run the script again. So this is the content of the first packet, and here you can see the 3 different layers, right? Exported PDU, CAN, and data. Okay, so we can use these layer names to access the different content. So for the first question, we need to get all the unique IDs. Okay, and as you can see here, the ID is part of the CAN layer. Okay, so we're going to use CAN. Now, we have field names here, okay, and we have values. So we are interested on the ID, but this is just the name, okay. But let's get the field value, or the field name, okay. It may be the same or it may be different. So how can we know the exact field name for each of these variables? What we can do is, let's go back to the script, okay. And what we are going to do is, okay, we know that there are 3 layers. So let me add here another print statement, okay. Add another line to differentiate the outputs. So what we're gonna do is print packet, okay. To access the CAN layer, you just need to do .can .field names, okay. And we just do Control X, yes, enter. We execute the script again, and here you can see these are the field names for the CAN layer. So the first one is the same ID. For extended flag is actually flags underscore XTD, and so on. This one is this one. This one is this one. and for this, etc. Okay, nice. Okay, so now we just need to access the ID, okay, of each packet. So what we are going to do is do clear. Let's access the script again. Now it's time to remove some of this because we don't need all of it. Okay, I'm just commenting the lines in case we need it later. And so the question is how many unique IDs we have. Okay, so what we're going to do is now that we can go through each packet and we can access the ID, I'll try to put this in a list. Okay, so what we're going to do is before the for loop, I'm going to create an empty list. Okay, so it's going to be ID underscore list. Okay, and the way you create an empty list is just by opening and closing square brackets. Okay, so that's how you define an empty list in Python. And then what we're going to do is every time we access a packet, we know that we can use the ID field, okay, to access the ID, and we are going to append this value to our list. Okay, so we are going to do append. So let me add a comment here, is appending ID to empty list, or to list, to ID underscore list. Okay, so we're going to do is append, I'm sorry, the name of the list, so, which is ID underscore list equals, I'm sorry, dot, the method is called append, and then just the ID of the packet. Okay, so it's going to be packet, we need to access the can layer, okay, and the field name is ID. Okay, so at the if we need to remove the break statement because now we need to go through each packet. Okay, and this will give us a list with all the different IDs, right? So let me show you really quick. After the for statement at the end, we're going to print all the list, ID underscore list. Okay, it looks good. Yep. And then we can do Control X. Yes, enter. Let me clear the screen and let's execute the script again. Nice. So there are a lot of packets. You can see all the numbers, and you see the single quotation marks here. It means that the ID is actually a string, is not a number. Okay, and you can see all the different IDs that are part of the list. But we don't know. I'm sorry, we don't need all the IDs. We just need the unique values, right? So we need to remove all the duplicates. There are different ways to do this. You can, for example, you can add a condition that says, if the value is already in the list, we don't need to add anything. Or another way could be, for example, once you have the list, what you can do is you can create, let's say, another element, let's say unique IDs, okay? And what we can do is, now that we have a list, there is a method in Python that is called set. So the set method, okay, and if you put inside this the list, ID underscore list, the set method will create a set of unique values. Okay, it will remove all the duplicates. So let's do this, and then we print the IDs list. I'm sorry, unique ID. Okay, and since they are asking actually for how many values are unique, we have the set, but we can do is also print the length, which is a built-in Python function that actually give you the number of elements within a set or within a list. Okay, in this case is unique IDs. Okay. And then we do Control X. Yes, enter. And then we clear the screen and we run this again. And here's the set, okay, with all the unique values, and there are 36 of them, okay? There are 36 unique IDs, and that's actually the answer for the first question, okay? 36 here. Nice. And if you want, you can also improve the output of this script. You can go and modify this, and let's see, you can do something like, you just need the number of elements, of unique elements. So you can do F and then double quotation mark and say question 1, okay, there are, and then curly brackets to specify the variable, which is the length. I mean, you can use a variable or also let's say basically an expression. So is between the curly brackets is I want to put here in this string the length of the set unique IDs, right? There are blah 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 unique IDs. Okay, and then we close this with a double quotation mark. That's it. And then we do Control X again, save, enter, we run this again, and you have the answer for the first question, okay, 36. Okay, so now let's go with the second one. For the second question, now it says, how many speed update messages are present in this capture? And like I mentioned it before, you can identify speed update messages by using the ID 589, okay? So what we can do now is, okay, so I created my empty list, right? I added all the different IDs to this list, and I created this object, I created a set, okay, of that list to get the unique IDs, right? So that was for question 1. Now that we have the list, I mean, there are different ways to do this. I'm not trying to create like the most efficient, the most effective script. It's just, you know, trying to answer the question. So what we can do is, I mean, we can use this for loop, okay, and define a counter, for example, or you can use another for loop to iterate through each of the elements of this ID list object, okay, and identify how many of them are equals to 589. So what I'm going to do is I'm going to use this for loop, okay, so I'm going here, and what I'm going to do is create a count variable, okay, let's call this count of ID 589, okay, and I will set this count to 0. So what I'm going to do here, and within this for loop, okay, I'm going to repeat here, counting, this is just a comment, counting IDs 589. So what I'm going to do is add an if statement, okay, and say if the packet.can.id is equal, remember, double equal sign. If this packet ID is equals to the string 589, right? Remember, how do I know that it's a string? Is because when I printed the list of IDs, we got the number, but there were single quotation marks to the left and to the right of each value. So that means that the element is actually a string. Okay. So if the packet.can.id is equals to 589, what I'm going to do is I'm going to increase that counter, right? So we're going to do count underscore ID underscore 589 plus equal 1. Okay, that's it. as simple as that. Okay, I'm reusing the for loop, and I've just, if the value is 589, just count 1. And then we can go down here out of the for loop at the end, and we can do print. Then we can do f double quotation mark. Let's see, question 2. Okay. Oh. And we can do there are, and we just need the variable, the count ID 589. There are the number, speed update messages, okay, or packets, no, whatever you want to use. Okay, so we are just counting. Okay, we are identifying those packets that use ID 589, which is the ID for a speed update message, and that's it. So let's see, Control X, Y, enter, and then let's run this again. Okay, so apparently there are 352 packets that use ID 589. And this is actually the answer for the second question, which is here. How many speed update messages are present in this capture? The answer is 352. Okay, nice. So now let's go to the last question. Is what is the maximum speed in miles per hour? Okay, that this vehicle reached in the capture, and we need to round this to the nearest hundredth. Okay, so this one I'll be very careful when explaining this concept, and I hope it makes sense to you guys. If not, please let me know in the comments of the video. So if you go to if you open this in Wireshark, okay, the value of the speed is under the data section here. Okay, so we are not working with a CAN layer anymore. We now need to access the data layer. Okay, and it's this value here. Okay, so this value is represented using 5 different bytes. Okay, and like I mentioned it before, if you read the solution guide, you will see that you can use all these 5 bytes to describe the speed value, but it looks like in this pickup file, they are only using the last 2 positions. Okay, so there is no need to focus on the first 3 positions. Okay, and each of these values are described using hexadecimal system. Okay, so these are hexadecimal values. Okay, and to get the value, okay, what you need to do is you need to add all these. You need to add these values. Okay, but it's not just saying, okay, this is hexadecimal, let's convert this to decimal, and just add the values. No, this is actually kind of similar to when you have numbers in the decimal system. You know, you have from right to left, you have, for example, the first digit express units, the second digit express tens, and then you have thousands, and then 10,000s, and so on, right? So think of these values as digits, okay? But that's the example that I just gave you is from the decimal system, but this is actually not the decimal system, okay? Since we have bytes, okay? So each element is basically an arrangement of 8 bits, okay? That's what makes a byte. So let me show you an example on how can you calculate the final value with these 2 elements, okay? So I prepared this short presentation here for you. So let me use this code, this color. Okay, so so basically what is happening is on the right side here, you have the C code that the NCL team shared with us. And here's the pickup of the file, okay? And let me delete this really quick. Okay, so in the code, right, they start their analysis in position 3, okay? And the reason is, like I told you, you have 5 different positions, but it looks like the first 3 positions, position 0, position 1, and position 2, they are always 0. Okay, so they start here in position 3. Again, this does not mean that we will always focus on position 3 and 4. There might be another capture in another system where you actually have all these values too. Okay, but for now they are not relevant for our analysis. Okay, so they take this value here, okay, and they execute this operation. They do a 8 bits left shift operation here. Okay, so what does that mean? Let's start with an example here. Okay, so we need to use these 2 values, and let's start with an example from the decimal system, right? This is what I was trying to explain to you before. Let's say you have the number 32, right? So this number 2, this represents the number of units, and this digit here, 3, represents the number of tens, right? So whenever you try to, how do you get the number 32 is you have 2 units, and then you have 3 tens, right? So we need to do kind of the same type of operation. Imagine that these are this 3b value is actually the units, and think of this as the number of tens, right? But instead of tens, what we have is 8 bits, okay? So instead of multiplying by 10, 8 bits, the whole number, the maximum number that you have there in 8 bits, is like multiplying to 8 times, right? So if you want to get the final number of these 2 digits, is actually you need to convert each of these values, 3b to decimal, and 1 in hexadecimal is the same as decimal, and then the position 3 value, okay, you need to multiply this. Instead of 10, you need to multiply this by 2 to the power of 8. Okay, why? Because it's, remember, 8 bits, which is a binary system, and then you have 8 of them, so you need to multiply them all together. So this is the maximum value that you can get on each byte. Okay, and then you will get the result, and this value, if you read the solution guide, says that this value actually has 2 decimal places. So that's why we need to divide this by 100. And that's how you get the value in kilometers per hour. Okay? So let's try to replicate this in our script. Okay? So let's go. I hope that explanation made sense. If not, please, again, let me know in the comments and I can record another video with more details. Okay? So let's go to the script. So we need to calculate the speed only for those packets, okay, that are speed update messages. So what we are going to do is we are going to reuse this if statement. So all the code to calculate the speed needs to be under this condition, this conditional statement. Okay, so let me go here. Oops. So what I'm going to do is I'm going to calculate the speed for just the first packet with ID 589. Okay. So I'm going to add here a comment. Okay. So this is calculating a speed. Okay. So we are going to do this for the first speed update packet. Okay, so now let's do this. So we know we are in the packet, and the first thing that we need to do is, okay, what is the field name, right, for the data? So let's print really quick. Print. We have the packet, right? We know that the layer is called data, okay, from the previous code, and for that layer, I want to know the field names, field underscore names. Okay. And then I'm using break for, this is for the for statement, just to, so this runs only once. Okay. And the reason why I'm using it this way is because the first packet is actually a 589. Okay. So that's why I'm just using if here. I know that this will run only once, and it turns out that the first packet is actually 589. So that's why I'm pretty sure that this if statement will be through and this code will be executed. Okay. Nice. So let's do Control X, Y, enter. Let's run the script. And here are the field names. Okay, you have data, data underscore data, and data length. So if you go to Wireshark, so this data underscore data is actually this value. Okay, this data field here is this one, this first line, like the title of the section. You have data, and that you have data length. Okay, so the field that we need to use is data underscore data. Perfect. So that will give us this this expression, this 5 bytes expression. Okay, so let me. Okay, so let's do nano access. So now what we are gonna do is, okay, so now we know that the so we can do print, okay, packet dot data underscore data. Okay, just to see what we get. I'm interested more on the format of the value, right? Because how can we access these positions 3 and 4, right? The last two positions of the value. Okay, so let's do Control X, Y, enter, and let's run this again. And here it is. Okay, looks like a string value. Okay, and it has 5 elements. Okay, length 5, and these are hexadecimal representations. Okay, 5 different bytes, and they are separated by a colon character, right? But I'm interested in these last two positions. Okay, position. So it's position 0, position 1, position 2, position 3, position 4. Okay, so the first task would be, okay, we need to split these values. Okay, so we need to separate each of the elements, and we are going to use the split function, and the separator is going to be the colon character. Okay, so let's do that. Nano, and what we are going to do is, okay, so let me show you here. I'm just using print statement so I can show you the output, and then at the end I'll put all the code together. Okay, so we do print, and what we are going to do is use the same packet dot data underscore data. So that will give me the expression, and this is actually a string. So there are different string methods that you can use. I'm going to use dot split, and then the separator is going to be a colon. Okay, close. Then that's for split, and another parenthesis for the print statement. Okay, and this should give me a list with every element. Okay, let's see. Control X, Y, enter. Let me clear the screen for you. Let's run this again, and here it is. We got a list. Oops, my bad. So we got a list with all the different elements, right? So now we can access specific elements. Why is this important? Because remember that what we need to do first is we need to convert these hexadecimal values into decimal values, and then to add them and get the speed value. Remember, this is like the units, this is like tens, right? So we are going to add this value in decimal plus this value in decimal, but don't forget we need to shift these 8 bits, right, to the left, so we can get the final number. Now, here are the elements. Okay, now how can we access, or how can we make reference to all the different positions, like position 0, 1, 2, 3, 4? There is another method that you can use. It's called enumerate. Okay, so this will basically map each value to an index that starts from 0, and we are going to use that index as the position. Okay, so let me do here nano again. Let's access the script. And what I'm going to do is I'm going to create a for loop here, okay, to access each of these, to loop through each of these positions, okay? But that for loop will be for two variables, okay? It's going to be the position, comma, and the value, okay, in, and here's where I'm going to use enumerate, okay? Enumerate, okay, enumerate, and then we just pass the list, which is this expression here. Okay, so let me copy this. Okay, so it's basically enumerating the entire list, right? And then just to show you really quick how this works, I want to print. I'm going to use a format. It's going to be give me the position, oh, curly brackets, position, and then the value. Okay, so you can see that we are mapping each value to an index that we will use as a position. Okay, nice. Okay, let's do Control S. Oh, I'm sorry, Control X. And then let me clear the screen and let's run this again. Perfect. So here's the list, right? And then when using an enumerate, the enumerate method, we are basically mapping each element to an index, which is the same as the position that we were talking about before. Okay, nice. So now we can, now we know how to do specific operations on values, hexadecimal values from position 3 and position 4. Okay, cool. Let's clear the screen. Let's do nano. Let's access the script again. So now we can start doing different calculations, right? So what we are going to do is we need the speed, right? So what I'm going to do first is I'm going to comment this because I don't need these statements anymore. And after the count, right, we need to calculate the speed. So what we are going to do is we are going to define a variable, okay? So this variable is going to be speed. Let's call it packet speed, okay? Packet underscore speed. Okay, so if the packet ID is 589, this packet contains information about a speed value, okay? And I'll set this to 0, okay? And then once we go through all the different positions, in this case position 3 and 4, we are going to add the values to this 0 value, okay? So what we are going to do is we are looping through each position, okay? So it's going through position 1, position 0, position 1, position 2. And now what happens if the position is position 3? Okay, so I'm gonna add an if statement here. If position, okay, equals 3, okay, we know that we are working with this position here, 0, 1, right? So if position is 3, okay, what we need to do is, okay, we are going to increase the packet speed value, okay, which is during the first iteration is actually 0, and we are going to add first we need to get the, like we said before, we need to get the decimal expression, right, of this value. And the way to do that is we are going to use the int method, okay, and we need to do the value for position 3. Okay. And then this comes from the hexadecimal system. That's why we put the 16 parameter there. Okay. So this is converting the value from hexadecimal, okay, to decimal system. Okay. Now, but remember that to add this value to the final speed, we need to shift these 8 bits, right? So there is a parameter that you, an operator that you can use, which is the less than, the double less than character, okay? So this tells Python to execute a bitwise left shift operation, okay? And then since we have a byte, and a byte is the combination of 8 different bits, that's why we need to use 8, okay? And that's it. Now, if the position is the last one, position 4, okay, we are going to add to the packet speed variable, we're going to use just int value, comma 16. Okay, since this is the last position, okay, similar to the units digit, there is no need to do any modification. We just get the decimal value and we add it to the final speed value. Okay, nice. And what else do we need to do? Well, remember that based on the information provided in the solution guide, the result will be an integer, okay? But that integer actually has 2 decimal positions, okay? Or 2 decimal positions, okay? So after the for loop, once we get the final speed, okay, we are going to update this value, packet underscore speed, and we are going to divide this, equal by 100, okay? So that will give us the value with 2 decimal points, okay? And it's going to be in kilometers per hour, okay? So let's do, okay, let's save this, okay, Control X, Y, enter, and we can do Python and then run the script. Oh, my bad, I forgot to print the result. Let me go here. Yeah, after the packet, we can just do print. We are going to print packet underscore speed. Okay. Control X, Y, enter. Let's run this again. And here's the speed for the first packet of the pickup file, which is actually a packet with ID 589. Okay, so this is the speed. But the question is not asking for a specific speed value, it's asking for the maximum value. Okay, so what we can do is, okay, let's go to our script again. So what we can do is, before the first for loop, okay, let's create a variable that is called max underscore speed. Okay, and this will be 0.00. Okay, so what we can do now is, okay, here, once we calculate the speed of every packet with ID 589, okay, what we are going to do is we are going to compare that speed value against the maximum, right? So what we are going to do is we are going to say, okay, after the for loop, we got the speed, right? And we are going to add an if statement, right? So if the packet speed is greater than the maximum speed, max underscore speed, what happens? We are going to update the maximum speed value, okay? So that will be, so max speed is going to be equals to packet speed, okay? That's it. So let me add another print statement at the end. So we're going to do print question 3. The maximum speed is, and we open a curly bracket to add the variable. Remember, it could be a variable or it could be an expression. It's going to be max underscore speed. Okay. Now, we need this in miles per hour, right? So there is still another operation that we need to do. Once we get, and this could be after the for loop, after the for loop, or we can do it, we can do it here also in the print statement. There is no need to add more code because, let's use this as an example of how can you add expressions. So whenever you're using print with this format, okay, with quotation marks, okay, this is column, okay. What we can do is, this is the variable, but this code will give you the result in kilometers per hour, and that's what they describe in the solution guide. But since we need this in miles per hour, there is a conversion factor that you can use. Okay, so you can multiply the maximum speed value, okay, and the factor, if I'm not mistaken, is this value here. Okay, so you can add more code at the end, or you can just use you can calculate the value here within the print statement. Okay, so let's put it here, paste. So this is the factor. Okay, so whenever you're using this printing option with a specific format, you can add variables or expressions within using curly brackets, and I'm using a variable, and then I multiply that result by this factor. Okay, so when you multiply the speed in kilometers per hour by this factor, you will get from kilometers per hour. If you multiply this value by this factor, you will get miles per hour. Okay, and since we need to round this to the nearest 100, you can use another function here called round, open parentheses, and to the result you just add comma 2, which means I want only 2 decimal places. Okay, I need to round this to have, I'm rounding this to the nearest 100th. Okay, that's it. So let's do Control X, Y, enter, and hopefully this works. So let's do clear the screen. Okay, we calculated the speed with 2 decimals. But I think I did something wrong. Let's go to the, is this iterating through each value? Oh, yeah, my bad. We left the break statement. We need to comment this too. So it was just giving me the value for the first packet, which is actually a 589 packet. Okay, so don't forget to remove the break statement. Okay, so now we can go through all the different packets. Okay, Control X, Y, enter. Let me clear this and let's run the script again. Yep. So out of the 352 packets with speed update messages, the one with the maximum speed, with the highest speed, is the packet with a speed value of 20.13 miles per hour. Okay, so that will be the answer for the last question here, 20.13. Okay, now before I finish this video, let me go through the script really quick so I can explain to you how we got to the how did we get all the answers. Okay, so let's do nano. Let me reduce the, hopefully it's clear. Okay, so this explanation is just in case you don't want to see the whole video and you just want to go directly to the answer. You can use this script. Okay, so basically the library that we are using is PyShark. Don't forget to install the library before creating the script. You can before running the script, you need to just open the terminal and run pip install PyShark, and then you create a script with whatever utility you feel more comfortable with. I'm using Nano. So the first line is we are importing the library, okay? And then we define the path to the file under this variable, pickup file. We are creating a file capture object, okay, using the PyShark library. And if I'm not mistaken, there are more parameters, but I'm just using the first one, which is the path to the file, to the pickup file. And we were going through each packet using a for loop, okay? And for the first question, we needed to access the ID. And remember that each packet has different layers, okay? And there are basically 3 layers: exported PDU, controller area network or CAN, and also data. And the ID is part of the CAN layer. That's why we use packet CAN, and then you can also access all the different field names. And we realized that the field name for the ID is actually ID. So when looping through each packet, we were appending each ID to this list, right? And then at the end, after the for loop, we use the set method just to get all the unique values from this list, okay? Because the ID, there are different messages or multiple messages that can use the same ID. So by using the set method, we can just get the unique values. And when printing the message for question 1, I use the unique ID set and I use the method len, okay, to get the number of elements, which gave me 36, okay? For the second question, we reused the for loop, okay? Again, I'm not trying to show you the most effective the most effective code. I'm just showing you one option, okay? Feel free to modify this code. So I'm reusing the for loop, and if the ID for a packet is 589, what I'm doing is I'm using a count variable here that started in 0, and then I was increasing the value of this counter by 1, okay? So after looping through each of the values, I'm just printing the count value, and it turns out that there are 352 packets with ID 589. Now, for the last question, okay, remember that the speed value is represented using 5 different bytes, and in this case, we only have values. In this specific use case, in this specific pickup file, we are going to use only the last 2 positions to get the speed value, okay? So what we are going to do is we are using a different layer. In this case, we are not using the CAN layer anymore. We are using the data layer, okay? And under the data layer, okay, there is a field called data_data, and that's the field that actually stores, okay, this value, this arrangement of 5 different bytes, okay? Now, when we printed this value, we realized that it's a string where each byte is separated by a colon character, right? So that's why we use the split method here with a separator equals to the colon character. So we got a list. So this expression is the result is actually a list. with a mapping to an index that starts in 0, and we are using that index as the position, right? So for each value, we have a position and a value. Now, when that position is 3, okay, we are getting the value, and we are converting that value from hexadecimal to decimal, and we are moving it, we are moving 8 bits to the left. Okay, so we are using this double less than character, which is basically the operator for a bitwise left shift operation. Okay, and then if the position is 4, we are adding to this packet speed variable, we are adding just the value of the decimal representation of the hexadecimal value. Okay, now based on the solution guide description, the result, okay, even though it's an integer, we need to use the last 2 digits as decimals places. So that's why we are divided by 100. Okay, and this is the result of the if statement. Okay, and once we get that, I'm sorry, the speed is the output of this for loop statement. And once we get that speed, we are going to compare this value with this max speed variable here. And if the speed is greater than this, we are going to update the max speed value. Okay, that's basically trying to find the maximum speed. Okay, and at the end, okay, when printing the solution, the result of maximum speed is actually in kilometers per hour. So we are multiplying by this factor to convert from kilometers per hour to miles per hour. Okay, and since the question is asking us to round the answer to the nearest hundredth, I'm using the round method here with 2 decimal places to get the answer in, with just 2 decimals. Okay, and that's how we got. So feel free to pause the video and use this script. Again, it is not the most efficient script, but at least it gives us the answer. Okay, and feel free to modify it based on your experience using Python. Okay, so let's do Control X. These are the answers for the 3 questions. Thank you.